So essentially, as you've already heard, this is going to be about the journey of chai and why. But you might be wondering, what kind of enlightenment am I going to bring you? If you think it is going to be this kind of an enlightenment, wrong number. The N in my enlightenment is nitrogen. The title is enlightenment is nitrogen. Nitrides have been my friends for a very long time. I started my research career as an undergrad student working on molybdenum nitride, and even now, after 30 years, I'm working on gallium nitride at TIFR, and nitrogen and nitride materials helped me start getting science out of the lab. And mainly this enlightenment has been nitrogen containing semiconductors that emit light. If you make LEDs, red LEDs are gallium phosphide doped with nitrogen, and the blue LEDs are, of course, gallium nitride. And the first thing when I was a graduate student, when the blue LEDs came up, we had these little kits where, this is in the University of Wisconsin, our outreach program there, we had red, green and blue LEDs whose intensity we could control, and we could mix it to show how white light was generated and how we could do color mixing. So this was some of the first work as a grad student when I was doing outreach, and even now in TIFR, after setting up my lab, we actually make these blue LEDs. So we grow the materials and we connect a little battery to it, and the lovely thing about these materials, they are visible and you can show people that you can grow a material and emit light, and this is what we really started off showing people. I was going to colleges, talking about things, going to schools, showing them how semiconductors work, talking about semiconductors, and then this got me started into this passion for going out and telling people what we are doing. And I thought I would get people excited about science. But as I found out, and you've heard in the last hour, it's not so easy. It's not so easy at all, because reality was a big thing, and it was a big learning experience to me to do science outreach over here. And the funny thing was, science underpins our life. You cannot do without this mobile phone, you cannot do without technology. Still, people seem to just not worry about it. It's okay if it's magic. I mean, you don't really worry about it. And we have somehow killed this exciting thing called science, the beauty of the joy of discovery, of discovering something about the world around us. The world around us could be a world around a star in a galaxy far, far away, or the world inside something in a cell inside my body, but the fun of science has completely gone. And when I went to colleges especially, or high schools, etc., science was essentially this. A bunch of formula that had to be mugged up, and people would say, can you help me solve this problem? And somehow I felt that there is a big disconnect, because the real world doesn't care about these artificial divisions we make between physics, chemistry, or biology. I mean, if you're looking at a flower under a microscope, it doesn't matter what you're looking at. And there was the other sort of more, which has also been discussed, that most of the research being done here, the science being done here, you can argue about the amount of it, let's not get into that, is by the taxpayer. The government is doing this. And still, we as scientists were not doing enough to go and tell the people what we are doing and why we find it. If we don't tell people that we are finding it exciting, why would they even bother trying to figure out? And despite India being the only country which has the fact that scientific temper should be inculcated, etc., in our constitution, we as scientists weren't doing anything about it. Wherever it was being done, and including my own department that TIFR belongs to, it's generally in what I call the information deficit model. That is, you don't know something, I am the scientist, I know something, if you knew what I knew, you would believe what I say. Right? Nuclear power is good for you. Or something of that sort. It was not an equal dialogue that was happening. It was more like, we know stuff, you don't know stuff. It was like teaching. And being in TIFR, I kept getting this thing about basic research. Okay, basic research was something completely outside. I mean, what ये scientists लोग थोड़ा पागल होते हैं was generally the idea that I used to get whenever I went outside. And questions like, why should I bother about fundamental physics? What good is it to me if I'm on the street? So this was one major problem. And the other major problem in the thing was, as I have said, in the way we were teaching science, it was all rote learning, you mug up stuff, and absolutely no feel for reality. And so many misconceptions in basic things, and we decided at some point that we need to just do things in a more fun way. Maybe that will work, and that led to Chai and Why. So Chai and Why is a science cafe. It started off as a science cafe. It's now, I think, much more than a science cafe. We have been running since 2009. Right now, we are every 2 weeks. We've had 224 sessions without a break. And I think this continuity has been very important, because today, even if I don't do anything for publicity, people know that there will be a session. Okay? And it is informal, it is fun, it is interactive, it is family friendly because we want to get public at large, and it is also becoming increasingly hands-on. It started off being a traditional science cafe. A traditional science cafe is a 20-minute talk about a big picture of something, followed by a long discussion over a cup of chai or whatever it is, coffee, or in the West it's also beer or something. You have long discussions. Okay, but I think more important than chai and why when we started off is what it has morphed into over the years. It has morphed into a platform where we test out things, and whatever has been worked has been translated into the local language, and we built on this to get science out to many places, at least in rural Maharashtra where have some effort there. And this actually was one of these random meetings which was a chance. Sanjana Kapoor, who at that time was running Prithvi Theatre, wanted to bring a play on mathematics. This was a disappearing number in the life of Ramanujan, and host it in the Homi Bhabha Auditorium in TIFR. Unfortunately, our auditorium seats were being replaced and it is not available. So, she was in the canteen asking how things were there. Professor Bhalerao is around here, he knows this. And we were discussing what we could do and how we could interact. And she offered us Prithvi Theatre. I mean, I had talked to coffee shops and all, but nobody was interested in science cover discussion. She was willing to offer it. It was going to be a 6-month trial. I knew 6 friends who would be there. We would have something once a month. But it was so popular that we very soon, people requested for 2 sessions. We became twice a month, and it continued over there. So right now we are at 3 venues in Mumbai. Prithvi Theatre, Juhu on the first Sunday. It's very important we are not in TIFR. People are scared of science. I don't want to bring them to me in my den, sort of thing. So we are at a public venue, which is a neutral venue, Prithvi Theatre, which is a venue for theatre. We are at a college in Matunga, mid-city, and if a month has a 5th Sunday, we are also in South Bombay in one place. And main thing is, people have lots of questions, but they don't know whom to ask. We are providing a platform where anybody can come and ask questions, but we also, we have the standard ones which are more like talk. This is not like dark matter somewhere, but we are also trying to do little experiments, because what we found is, in general, especially children, they have fantastic textbooks with neat blue boxes, which are supposed to be things that are to be done, but they are never done. They're never done. So there is even as simple experiment as covering a candle, burning candle with a glass. They read about it, they don't do it. So doing experiments is very important, and we've started a good bit on that. And we cover a whole range of topics, and some topics we know which will work. These are things in the news. I'll give you a few examples where we know the public will have questions. Anything that kids would like is always a great topic. The kids drag their parents along and bring it, and things where you can do things with your hands, and of course, once in a while we just do wow experiments, because there's nothing like it to sort of get that curiosity back. Who comes? Well, public at large. People who are willing to wake up on a Sunday morning for science. General public at large. If there are kids, there's no problem. The kids are always very curious and interested. Small kids, big kids. We allow people to bring children of all ages, as long as they're not going to be very disruptive. It's okay if they're walking in the corridor as well, because we know there is no childcare available. What will they do? If we want parents to come, they have to bring their kids with them. And somehow, even though it is meant to be this very informal forum, we cannot get away from the point that even at places like this, people come and religiously take notes. Okay. One has to be very creative in making it popular, and the title matters. The title really matters, and one of my roles is actually, I don't do these sessions all myself, though if there is, the reason for this continuity is, if I can't find a speaker, I will do something, and I've done almost 30 of them myself. The important thing is to find an exciting title. So a few years back, words like 2G and 3G were on the front page of every newspaper, generally followed by the word scam. So, okay, but I went and asked a few people, what is this 3G? Do you know what a 3G thing is? What is the difference? Nobody knows. Now, we could have talked about the fundamentals of wireless communication, but I don't think people will wake up on a Sunday morning for that. But we had this session called 2G, 3G, ye sab kya hai ji? And believe me, it was packed, right? Similarly, terahertz spectroscopy, the person doing it was like, I don't know how many people will be interested in terahertz spectroscopy. We just made it up, tera kya hoga? Okay, and this was again, good enough reason for people to come in. So Chota Bheem is on motor proteins. Something new broke the speed limit for the faster than light neutrinos when that happened. There was a song which went viral. It was called Why This Cola Very Deep a few years back. So I use it as an excuse to talk about the science of colas, carbonated beverages. And even we've done mathematics and folk tales, which is add a boon and subtract a curse. So some of these. Sometimes actually, you know, the most difficult people to convince in coming up with these fancy cool titles is the scientists themselves. So of course this didn't require convincing, it was me, but we had a young grad student who was working on gamma ray bursts. Okay, and when she talked, she said she would like to do a Chi and Y. I said, great, what are you going to talk about? Gamma ray bursts. Gamma ray bursts, okay. So immediately, I am this old Hindi movie kind of person. So old. Okay. This song occurred to me, which was, you know, Sare ke Sare Gamma ko lekar. Okay, and I said, okay, let's make it Tare ke Tare Gamma ko lekar. And she was like, no, you know, that's not correct because the energy of the gamma ray burst is so much that it cannot come from a star. Okay, I said, that's fine, but you know, maybe what you can do is, we'll keep this as a title, and when people come in, you can start by saying, by the way, thanks for coming, but you know, I cheated you, the title is wrong, it, you know, cannot be something, but at least because of this title, people will come. So I think sometimes we have to take a little bit of creative freedom with, you know, sort of advertising our science. This is of course from, you know, this 2G, 3G, we basically discuss spectrum occupancy and how that works with a more cool title. So we've done everything from malaria to India's space mission, stem cells, mathematics behind the financial crash, Indus Valley scripts, exoplanets, science and art things, lasers, you know, a lot of different topics over the last 9 years. But the most important thing I think for us is, where is Shivram? Echo and chamber. What you talked about earlier, echo and chamber, we have used this I think very creatively, very successfully. We were perhaps the first scientific institute to be on Facebook. Facebook is now the place from where most of our audience comes. It provides the platform for people to ask questions to us. We have about 6,900 followers who follow the page. We reach 5,000 to 7,000 people every week. And now it's become, I mean, it's got more followers than the TIFR page, so even all the TIFR events get announced on the Chi and Y page. The problem is I don't have anybody to maintain it, and it's very difficult if I'm away for 2 days to answer, you know, even if a very small fraction of the 6,900 ask questions, somebody has to reply to them. We are at Chi and Y. If you're ever on Facebook, please check us out, like us. The other big thing was summer specials. So during the summer vacations, we decided now our average Chi and Y was initially pitched at sort of high school audience. You know, I was used to dealing with 10th standard, 12th standard kind of kids. But then we realized that no, we should probably make even the average slightly lower. But in the summer vacation, the 4 Chi and Ys which coincide with the summer vacation in Mumbai, we want to ensure that even a 7-year-old will get something out of it. And these generally tend to be hands-on. So last year we had Mahan Maharaj fold paper and make various platonic solids. It was World Cup season, so we looked at how football kicks bend. We did the science of baking. So all things which even a 7-year-old can do something, even if they don't understand the whole thing, it's okay, but at least they're excited about it. We've done origami and mathematics, showing how you can fold papers and do things. We also have sessions which were like science in the kitchen, science in the bathroom, science on the playground, science on the beach. Science on the beach is looking at granular matter and its properties, why half-filled bottles don't roll down. And the session nearest to Holi is always on color. The session nearest to Diwali is always on light. So we've had this color and chemistry and the candles for Diwali. So we've always done these hands-on sessions for Holi and Diwali as well. And the other thing it's sort of taught us and also given the public a view that scientists aren't these weird guys in white coats or whatever. They're just people like all of us. And here's an example. This is Ankuna giving a talk on chemistry. And when she was giving her talk, this was her son at that time. It was just at the back of the room. That's the chai waiting to be served, cups over there. And we're also people with families, with kids. We're all on a Sunday morning, we're all come together. And this, I think, has opened up this or reduced this barrier between scientists and the public quite a bit. And now it's getting really popular. We don't actually, a good Chi and Y is 100 people because then there's interaction. If 500 people show up, it becomes a lecture. Not everybody gets a chance to ask questions, but once in a while things like this happen. This was Shiraz talking on black holes where you can't even see these are the front row of the seats because everybody's sitting on stage over here. He barely had space on stage to even move about. And this happens because on Facebook, sometimes if without your knowing, events go viral. So normally we get 7,000 people looking at our page every week. But just in 2 days, somehow the reach went to 78,000 and 7,000 people actually saw it and shared it, and as a result, we never have to do this ever. but we had to install airport style these security barriers to make people go in a snake form. We had to do that at Prithvi Theatre, and people on Facebook were posting stuff like this, saying that I heard the theatre people tell each other that maybe this was a record attendance at Prithvi. They were wondering really hard why so many people had suddenly turned out for a science talk. To them, Shiraz Minwala seemed like the Zakir Hussain of science. They went further to know the Zakir Hussain himself would have drawn such crowds to Prithvi. Okay, so we are certainly attracting people. People have started organizing field trips to Chai. We don't do this. We don't have a poster, but some organization is organizing a field trip. Some research scholar is going to talk about this someday something. Depart sharp from something, and you will Borivali at some point, and food has to be carried by the child. This is not a picnic. Okay, but people are busing kids into our Chai and Wai sessions. This is a new model for. Okay, but it's okay as long as people are coming. I don't mind. So let me now switch and talk about beyond Chai, because I think this is the more exciting part. So we were doing these experiments. Some experiments you can make out that the public is sort of responding, they're interested in it. Some of them are well, okay, you realize that this one really didn't work out, concept didn't get across. So we combined stuff from science in the kitchen and science in the bathroom to make a thing called the Wonderful Lab called Home. The Wonderful Lab called Home was a series of experiments, 90 minutes, can be more, can be less, which is all things which you can do with standard stuff available in your kitchen, in your bathroom, that you can do it's like a little demo session. And this I tried out in many places. Mumbai schools were really hard. Pune was my first place where I actually figured that it's so much more exciting to talk about science in Pune. Ashok Rupner is there somewhere. You had helped me with this the first time we did it. I forget the name of the school. And then I did it in Sikkim. I've done it in lots of places across in schools. And I think the biggest thing we did was we translated this into Marathi. And I must thank Surendra Kulkarni who works with us. This is Har Namachi Prayogshara, means the same thing, the Wonderful Lab called Home. And this has been really, really popular in schools in rural Maharashtra. We've been organizing science camps as well around Mumbai, where we've tried many of these experiments. This is of course not from, this is from Rasayan Shastra Til Gamti Jamti, Fun with Chemistry, a bunch of experiments which we had done in 2011 for the Year of Chemistry. But we've been going out, mainly the model is, this is extremely low budget because we don't have funding for this mostly. What we do is, we know where the TIFR employees are our main resource. They come from generally places around Maharashtra. I don't know the school in their village, but they say, okay, I grew up in this place, I can put you in touch with my school and we will go there. And they offer us their homes for stay, so our stay is free. Our expenses are and we do this typically on 3-day weekends, where we can, it's sort of worth it to rent a Innova or a Qualis-like vehicle, pack it with stuff, 2 people. You go there, cover a bunch of schools in the morning, a bunch of schools in the afternoon, etc. for 2 days. Go to the surrounding areas, because once you contact one school, you can ask them, okay, are there a few schools in your vicinity, who has the largest ground, we'll do it there, etc. So this is a region near Dapodi, about 200 kilometers from a little more, from Mumbai, where we did some chemistry experiments. This is in Marshiras. The fun part is getting kids to do experiments. Forget kids, even teachers want to do experiments. Many of them have never got a chance to do experiments. And it's very nice. We can't obviously give everybody a chance, but it's really nice because people in cities they are it's almost teacher ne jabardasti bola hai attend karne ko, isliye they are there. They don't want to be there, or they are playing with their phones in the back. I don't want that crowd. This crowd is so much more exciting if you want to do it. Some of our people, this is with Mandar, they went once to the Bench Tiger Reserve in a tribal area, where they actually, the number of people was not much, but it was really nice. They had to get schools, because there were schools there, but the schools were locked. They had to get them opened and get the students and then do the experiments. But they had a good time. But when we mean by out of the lab, we have really done experiments in all kinds of places. This is near the sugarcane belt. If you go off season, this is a grain silo. The grain silo is empty, and we've used the grain silo as a venue. This is an outdoor venue. This is in a hostel where they didn't have any space, so this is we just use their beds as a table where we could do our experiments. Equipment is stolen from the mess, and you can see this is equipment like the apparatus is all here and oranges, etc. So it's all pretty safe. You watch everything. What works are actually very simple experiments. Very simple experiments. The experiment of a candle being covered, up till now, wherever I have gone, whether it is international schools, whether it is rural schools, the fraction of kids and teachers who can tell me why a candle goes off when you blow on it, or why a candle goes off, or the details of what happens when you cover it with a glass is about the same. And you just look at the kids; they've never seen this. They know about it. Okay, they all know about it. They've read it, but they've never done it. They've never seen it. Okay, and this has this also. See, when we started off, we were very clear that we want to get kids excited about science. We are not into science education. We have the entire HBCSE which does pedagogy and education, etc. But increasingly we find that once you start doing it, you are sort of also getting into addressing misconceptions, doing experiments which try and do that. I'll show you a few slides of it. So simple things like you take two candles, not one, a tall candle and a short candle, and you cover it with a glass. Clearly, when this is when this has gone off, this is still burning. So all the oxygen did not get over, right? The one where you put it with water, or you can use a simple tea strainer to show that the candle is actually hollow. There's a region in the middle where there's no flame at all. Yeah, when you put one candle and cover it with a glass, the water rises a tantalizing 20%, which tells many people to believe that 20% was oxygen. Right? And then we put two candles and three candles, and we show that I can get as much rise as you want. And we then make them think, and we often don't tell them the answer. We want them to go home and think, what is happening? Why could it be? What's going on? We also do some dramatic experiments. Dramatic experiments are, to me, the ones, if you see them once, you will never ever forget it. And one of them is magnesium burning in dry ice. Now, this carbon dioxide does not support combustion. It's such an ingrained thing. It's used in fire extinguishers and something else. Magnesium burning in air is itself impressive. It's bright. Magnesium burning in carbon dioxide is way brighter because it dissociates the carbon dioxide and burns almost in pure oxygen. And when you put it in a lump of dry ice, it's got this little smokes and spark flying, and it's just dramatic. I mean, you will never, and it's the brightest thing around. So it's a really great thing. Flame tests. Now, most places, even in schools, they do flame tests, but these are you take some wire, dip it, put it in a flame, ask your neighbor what color it was, you can't do this for 100 people, or 250 people. What we do is, it's very simple. These are candles, okay? And we have these little spray bottles, perfume bottles that you can buy, empty bottles. We fill them with a suspension of some salt in methanol, and we just spray it, and it creates a little fireball which is colored. And you can see this at the back of a large hall, or when you have 100 people, it's not a problem. And this is quite dramatic as well. You get this, red fireballs and green fireballs, and kids love this. Then we start into how it happens and what happens, etc. Also, the scale of experiments sometimes makes a big difference. Everywhere in the world, people do experiments with cornstarch water. Cornstarch water being a shear thickening liquid. As long as you 50% cornstarch in water, you mix it, it's solid. As long as you keep stirring it. If you leave it, it's a liquid. It's shear thickening. Now this is fun. You can play with it. You make a laddu, it's solid. The moment you leave it on your hand, it sort of drips through. The fun is when you make large scales of it. Now this is 200 kilos of cornstarch, 200 liters of water. Okay. And this we made a big pit. People could run on it, dance on it. You can dance on it. The moment you stop dancing, you'll fall inside. Okay. So as long as you're active, it's fine. If you hit it, it's fine. It's solid, but you do it slowly, you go inside. So this gives you a very different feeling of science is fun kind of stuff. Soap bubbles. Soap bubbles are also a very nice way to look at interference colors, etc. But soap bubbles don't last for very long. They just burst. And so we came up with this idea of making, not our idea, we've been looking at many things, and most of the things, we look at what other people are doing, learn from them. Often we have to sort of make sure that they work in the humidity conditions that we have, and the kind of quality of materials that we get. These are flowing soap films. So we start off with a soap solution in a tank, two little thin wires, let the soap solution drip along the wires, and then pull these wires apart, and you can get soap films which are half a meter wide, meter long, and these will last for half an hour, 1 hour, depending on, of course, how much wind there is and how much soap solution you have on top. And the beauty is not only can you talk about colors, but you can show people turbulence effects.
If you take you can wet your hand with soap water and put it through it, and you see how vortices are shed by putting something in it. So you can do lots of very interesting things with flowing soap films. The other category of experiments which I think are always, they always work, are experiments which involve things to eat. So experiments with ice cream, and in particular for the year of crystallography, we came up with this one, which is looking at different crystals, structures of cocoa butter. So apparently cocoa butter crystallizes in 6 possible forms between 0 and 50 degrees. Only one of them is the right one for chocolate, because it melts. The reason good chocolate is nice is it melts at 32 degrees or so. So if you put it on your tongue, it will melt. Now, if you want that particular form, you have to cool it very slowly. If you quench it, you get other forms which melt at 15 degrees and hence are in India are sort of liquid. And which is why if a chocolate melts when you keep it in the sun, if you keep it in the fridge, it never ever becomes the same. And we did it by putting chocolate in hot water and then ice water and slowly cooling it, quenching it. And the beauty of this is all experiments, good or bad, get cleaned out. So addressing misconceptions is something which, actually I didn't realize. I mean, I know how I went through school. I was just mugging up everything I was told. I didn't realize how bad things were until my daughter went to school and started showing me her stuff and asking me questions. And this is, for example, the drawing of the solar system in her book, which is quite misleading. So we were wondering how do we make something which is more realistic, and we came up with this. So this is my solar system. That's the sun, and this is scaled. Everything is scaled to a 10 centimeter sun. So of course, in this case, the sun. I mean, it's a fruit. I do whatever I get, coconut, fruit, something. The guys in the Sarkari Bhandar now knows me because I go with this measuring strip and I start measuring fruit. And they ask me, what are you doing? Why are you measuring the circumference of fruit? Because I'm trying to tell them that I want a 10 centimeter diameter fruit. But anyway, so Jupiter and Saturn are 2 marbles. Uranus and Neptune is Vatana, white and green Vatana, gives you the color correct. Earth is a mustard seed. Mars is a poppy seed. This is Rava, and this is a carefully chosen piece of Rava under a microscope to get a 0.2 millimeter piece of Rava. So Suji and everything I basically found at home, or from a kid's play kit. So we now have this model of the solar system which is to scale, and we can also do experiments where, given that now this is to scale, what are the distances between the planets? And this is when people realize that you can tell them how empty the solar system is, because in this auditorium, if I start with the sun at this corner, I would barely get to Mars at the other end. Perhaps not even Mars would be outside. And Jupiter, Pluto. Okay, for me, Pluto is still a part of the solar system. This is a scale where Pluto is 1 kilometer away on this scale. So we make kids actually walk it in the law. The other thing is, somehow this concept of everything is natural, it's chemical free, right? And this is with Ranjan, we try to do a chai where we would tell people that look, nothing can be chemical free. Water is a chemical, everything is a chemical. So this is the a banana, and these are the ingredients of a banana. Okay, and we also, I didn't do a good job of cropping it, I guess, but there are these companies that sell all natural shampoos, right? And all natural shampoos obviously have, if you add up, this is a 200 milliliter bottle, 200 milliliter, yeah. You can add up the amount of natural, the herbal ingredients. This is a herbal shampoo, 100% herbal natural. You will hardly get that in the 200 milliliters is less than half a gram of this, right? Most of it is sodium lauryl sulfate as surfactant base, and then people don't read. I mean, you have sodium benzoate, methyl, iso, whatever, all these things, and this is chemical free. Okay, this is all natural and chemical free. So I mean, we did when we started Chai and Why, we were not doing such things, but now I think it is in the interest of science, and we also have some sessions where we talk about issues like this. We've been able to get to places where we never thought that we would get in. This is in a madrasa in a village in Aurangabad district, where we could actually, this is another experiment which always works well, chemiluminescence. We could actually get a male and a female participant to do an experiment together. And I was wondering whether we would get beaten up or not, but it worked well. It was fine. And for us, the reward has been the look on the kids' faces, the excitement that we have. You can make out that there is curiosity. Curiosity is there no matter where you do these experiments. Everybody is interested, and this aha and the effect that they've actually figured out something, and the expectation of what's going to happen. This is fantastic. This is an amazing feeling. So I'm going to stop here. I mean, summarize here, not stop here. So we have various routes for sharing our science with the larger community. Chai and Wai being one of them. Chai and Wai is now sort of firmly established in the Mumbai calendar. In fact, we have even trademarked that logo and the thing, because people were trying to ask me whether they could do a tell me why with chai and other variants of it. So we like people to go ahead and do similar things, but just don't copy the format totally, especially if it's not, because this is associated now with the IFR. There's nothing like experiments. Many of our experiments, of course, don't work sometimes, but that's part of the way it is. We are learning. If you're eating oranges this winter, please take your orange and squirt it into a candle flame. You get beautiful fireballs. A very simple experiment to do at home. And for me, it's sort of discovering the fun in fundamental research. And I'd like to thank, of course, all our venues who have supported us, Prithvi and Parel. We were at Ruya College for about a year, and the new venue is Alexandra School. And of course, as I said, I don't do it. It's a series of speakers. TIFR students, TIFR faculty, some visitors at TIFR who've done it. We've had volunteers, and most important, the Mumbai audience who come to us. And there are two people I would especially need to thank. One of them is Surendra Kulkarni, who manages all the logistics, has translated everything in Marathi, and does a lot of coordinates on our rural activity effort. The other one is half of the sessions that I've done are thanks to my daughter, who's asked me lots of questions and pointed out things in her textbook which she didn't understand, and I figured, like, can I make this any better and do something to make it better? And she's a willing accomplice for most of these experiments. Many of the science in the kitchen things have been done by her. She also helps me in many of these things nowadays. So I'd like to thank her. And I want to end with a song.
ताज वो शम्मा है उल्फत के सनम खाने की, जिसके परवानों में मुफलिस भी है, जरदार भी है। रंगे मरमर में समाए हुए ख्वाबों की पतंग, मरहले प्यार के आसान भी दुश्वार भी है। दिल को एक जोश इरादों को जवानी दी है। शहंशाह बनवा के हंसी ताज में।
So this is one song. I figured the age group out here would relate to this song. I tried this once in a school and they had no clue what it is. But for me, just replace the word Taj with science and Pyar with science. Science is something, jiske parwane muflis bhi hai, zardar bhi hai. You have people from all kinds of people you can relate science to. The things can be easy, things can be tough, but the main thing is दिल को एक जोश, इरादों को जवानी दी है, and that for me is what I find. I am enjoying the journey at an institute of fundamental research, and this josh comes from taking science out of the lab into the public. Thank you very much.